Hello, welcome back to the channel for another tutorial related to workflow automation using n8n. If you are interested in learning how you use n8n to perform data analytics, you find the right video. My name is Samir, I'm supply chain data scientist and founder of the startup LogicGreen. Over the past few months, we have implemented multiple analytics products and workflow automation, mainly relying on Python. Our products were in the form of FastAPI microservices that were connected to ERPs, warehouse management systems, or planning tools. But for some time, we were using this low-code platform called n8n to implement basic to advanced workflow automation. The main advantage we had is that we could provide visibility to our customers that don't have the analytics or the programming skills that we have. However, when we needed to perform some data processing tasks, we were relying on external APIs that we were developing using Python, because this is the programming language that I'm the most familiar with. The problem was that some customers were complaining about this black box in their workflow, provided no visibility of what was done and was hard to maintain. This is why I did the experiment of learning how to use the n8n native code nodes to perform basic data analytics and data processing tasks. In this tutorial, I will share with you one of the experiments. We are going to build together a workflow to perform data processing to create ABC and Pareto charts. The workflow template will be shared in the video description, and I also share a link to a Google Sheet so you can recreate this workflow in your instance. Before starting talking about the n8n workflow, let me show you what is the objective of this experiment or this exercise. So this is the user interface of the public demo of the LogicGreen apps. It's a set of modules that are hosted in a FastAPI microservice and connected to a Streamlit UI. The idea of these apps is to showcase the capabilities that we have in LogicGreen to help companies improve their supply chain using data analytics. Let's imagine a scenario where you are working for a retail company that has hundreds of stores and thousands of references, and you want to support the inventory team to allocate their resources on references that are very important for the turnover contribution. For that, you can use a tool that is called ABC analysis or Pareto analysis. So the Pareto analysis starts with that. And here we're going to have two charts that we want to generate using Python or using n8n. So the first one is the Pareto chart. It comes from the Pareto law that says that 20% of the causes are making 80% of the outcomes. And here in our case, we want to know what is the percentage of sales that is caused by the top 20% of the reference. So for that, you are plotting the percentage of sales versus the percentage of SKUs, and you compare that with the 2080 mark. It's a very simple chart. And then you have the second chart, which is the ABC XYZ chart, where on the x-axis you have the contribution in the turnover, so here in sales quantity in units. And on the y-axis, you have the coefficient of variation, which is the standard deviation divided by the mean, mirroring or describing the demand variability. So the objective today is to generate these two charts. How to do that? So first, as inputs, we are going to use this Google Sheet, where you have on the sheet input data a sample of transactional data. So first, you will be able to access this Google Sheet. I will share that in the description. You can make a copy and replicate that so you can play with the workflow yourself. What can you find in these sales transactions? You can have the SKU number, the item number. What's the difference here in this case between the SKU and the item? Basically, an SKU is an item linked to a store. So here in our case, what we are going to take as a kind of a basis is the item, because we want to know the sales across multiple stores. Then you have the family, the category. We don't need that. You have also the store. We can use that in one of the visuals that we are going to build. Then you have the day, and then you have the sales quantity in units and the turnover, which is the sales quantity in euros or dollars, depending on your currency. And what do we do? What do we want to do with that is to build the same visuals as you've seen in the LogicGreen apps. So the ABC XYZ analysis and the Pareto chart. But unlike the app here, the data processing that you can find here in this sheet for the ABC XYZ analysis, the daily stores sales here and the Pareto analysis are not done using Python, but they will be done by an n8n workflow that we are going to build only with JavaScript code nodes. So here is the workflow that I've just run to show you the visuals in the Google Sheet. This workflow will be shared in the link in the description so you can run it on your own instance. So first, for debugging and just simplicity, I use a manual way of launching the workflow, but of course you can trigger it with more advanced nodes. Here we are just connecting to the Google Sheet and extracting the first sheet that I showed you, which is the one of input data. It's not the first sheet, but the one if input data to have this transactional data ready. Here, just for the sake of making the workflow fast, I only took 17,000 transactions. You can do more depending on the power that you have on an instance, but that's one of the limitations that you may have if you use n8n. Anyhow, then the first step, what do you want to do? You want to filter out zero sales. Why? Because you are not interested in transaction without sales. So for that, you don't use JavaScript Code node. What you do is you just remove all the transactions that are equal to zero, where the quantity, is equal to zero. And if the quantity is equal to zero, the turnover is equal to zero. Then you have multiple subflows. So we are going to put the focus on the top one and the bottom one. The top one, with the two nodes here, are going to prepare the data for the sheet that will feed the Pareto chart. The first one, we are going to group the item, to group the sales by item in quantity and in turnover. And then for the second one, we are going to perform some advanced processing to have the data ready for the Pareto chart. And the last one, it's where we are going to compute some statistical KPIs, which are the mean, the standard deviation, and the contribution of sales, which is not statistical. So that way we can have the x-axis, the contribution of sales, and the y-axis, the coefficient of variability. But first, maybe if you are more familiar with Python, I will go to, as I told you, I have implemented that in FastAPI to show you how it's done using Python. As I told you, in order to test the difference in speeds, I wanted to deploy the same workflow inside a FastAPI microservice. And here, this is what I did, where you have two different endpoints. The first one, launch Pareto, will only process the data for the Pareto chart. And the one, ABC XYZ, are only going to process the data for the ABC XYZ chart. What I can say is that both are using the class speed analysis that includes all the functions to do the processing. And we are going to start to tackle that. So for you to understand, let's imagine that you are like me, more familiar with Python than JavaScript. I will quickly explain you what the workflow is doing. So that way, when I show you that on JavaScript, you can connect the dots. So first, what we do, we load the data. So here, for the sake of the experiment, I assume that we don't push the data to the backend. The data is already available because I want only to measure the processing time. And then we do the first step, which is removing all the transactions that have sales that are zero. Here, I only take positive sales because I don't have negative anyhow. Then when it's done, we can start preparing for the Pareto chart. So first, we need to aggregate the data, and you know that if you follow the tutorial on the other video of this channel, we need to aggregate the sales by item. So we are going to aggregate the sales in turnover and in quantity. So that way, for each item, we know across all stores, across all days, how much units or euros have been sold. Then we can calculate the cumulative sum of the turnover. So that way, and then we can, first reorder that from the top to the bottom. Because as I told you, we want to know what are the top 20% making in terms of percentage of sales. So you reorder by the top, and then you calculate the cumulative sum of the turnover, and then you divide that by the total, so you have the percentage of shares, which will be the y-axis. Then you rank the SKUs, you calculate a percentage of ranking, which would be the x-axis, and then boom, everything will be ready. You calculate that in percentage, and everything is ready for your Pareto chart. It's very easy. For the ABC XYZ, so let's remember, x-axis, we want the contribution of sales. So again, we have to do some aggregation, but we also need to have the standard deviation and the mean to calculate the coefficient of variability, which is the y-axis. So we do all of three in the same time. Then we calculate the coefficient of variation, which is the standard deviation divided by the mean. And we can calculate the total sales to get the percentage of shares, which will be the x-axis. So we have the y-axis, the x-axis, then we can sort. We can then reorder by the highest contributor to the lowest contributor. And here, instead of doing a Pareto analysis, we can map it with classes. The top 5% of reference are A class, then the following one, so the 15% that are following are the B classes, and then the rest are the remaining 80% are the C classes. And then everything is ready to create your ABC chart, and then we can send to the endpoint of Pareto, the data set for the Pareto chart ready, same for the ABC XYZ. So how can we do that using n8n? So as I told you, we are going only to focus on the top and the bottom row because these two were not included in the FastAPI microservice. And when I'm going to rerun the workflow to compare the speeds, I will not include them. But for your information, if you want to know how to transpose or calculate daily sales, I will keep that in the workflow that is shared in the link in the description of the video. So first, we need to aggregate sales in turnover and quantity by item. So for that, we are going to initiate a dictionary. This dictionary, as keys, we are going to take the items, and then as values, we are going to take the turnover in euros or dollars and the quantity. So how we do that, we are going to loop over all the different rows of the table, that here is called items in the n8n denomination. And for each row, first, we are going to check if the item is part of the keys. If not, we are going to initiate it. And then we are going to increment the value of the turnover with the turnover that is taken in the row, and we are going to do the same with the quantity. And if you do that over all rows, for each item, you have the total turnover and your total quantity. And then you sort that from the top to the bottom, as a descending order, and then you render that in JSON format. So then you have one record per item. This output is taken by this node, where we are first normalizing the data, just in case resorting it from the top to the bottom, even if I think this step is not mandatory, but just in case, here we are talking about n8n, we are talking about maybe data that is not clean or maybe issues that we may not face. So this is a kind of a careful step to have. So for that, of course, we are going to take as the input, so the items, the input that we get from the previous node, and then we are going to use this math function to normalize the turnover and the quantity, ensuring that it's a number, and if it's empty, fill it with zeros. And then, so here I put turnover equals quantity multiplied by unit price, just for your information, but I don't think you need that. Then we create two different variables. So first one is to calculate the number of SKUs. So this is the length of the table that we have. And then we calculate the total turnover. This will be used for the ABC analysis. And then what we need to do is to calculate, if you remember well, what we need for the Pareto analysis is the percentage of SKUs in x-axis. So for that, we rank the SKUs. That's what we do here. And then we calculate the percentage of these ranks. So we divide these ranks by the number of SKUs. And here we only take the six figures after the comma, and we calculate the percentage here by multiplying by 100. But also we need on the y-axis the accumulation of turnover. So for that, we use this variable cumulative turnover that we increment each time with the value of the turnover, and we calculate the percentage value of that by divided by the total turnover. In the end, what do we have? We have the ranks from the top, from first to n, and then the cumulative number of SKUs, that will be our x-axis, and the cumulative, cumulative of SKUs here in percentage, here in absolute value, and here the cumulative number, like cumulative quantity of turnover. So that will be our y-axis. This data is pushed to the sheet Pareto, and these two columns here, cumulative SKUs and cumulative turnover, cumulative share, of turnover, I used to generate the Pareto chart. Okay, so now we can start to build the ABC XYZ analysis. The first step we are going to do is we need to compute these statistical metrics that are used for the ABC XYZ analysis. And the statistical one is the coefficient of variation, which is the mean. Here we are going to define it as a function, and the standard deviation. And then, based on that, first, now that we have the two functions, first we need to calculate, like we did for the Pareto analysis, the aggregate sales, because let's not forget that the x-axis is the contribution of the sales in the turnover. So for that, the same like we did before, we initiate a dictionary. We initiate also a variable that will calculate the total quantity, and then we loop over all the items. We take the item, the day quantity, if the item doesn't exist, which is the key of the dictionary. We initiate the dictionary, and then we increment with the quantity. So then for each item, we have the total quantity. Then what we can do, we can for each item and the day map, we can. Okay, so now we can tackle this ABC XYZ analysis. It will be a bit more complicated because now we have to calculate some statistical KPIs. So what we need is, on the y-axis is the coefficient of variability. So we need the mean, and we need the standard deviation. So we define functions for that because that are going to be used later on the distribution, the daily distribution of the different SKUs. But first, what we need is to calculate the x-axis, which is the percentage of sales. So for that, we know already the recipe. We initiate a dictionary that will be used where the key will be the item, and then the value will be here, the quantity, the sales quantity, and then we calculate the total quantity. And then so we use this variable for the total quantity per item. And then what we do is very simple. We loop through all the different items. And if the item is not part of the key of the dictionary, we initiate it. If not, we increment the value with the quantity. So that way, when you have finished your loop, each item will have the total sales quantity. And we also increment this variable total quantity. So that way we have the overall quantity for all items that will be used later. Then we need to calculate the metrics per item. So for each item, you have the sales distribution, daily sales distribution. And for each distribution, we want to calculate the total quantity, the mean. So for that, we are going to use the function that we have defined before. The standard deviation. Again, we apply that on this object that will capture the daily, basically the sales distribution per day for each item. And then we calculate the coefficient of variability. Let's not forget here we are looping through all the different items with their respective distribution. The coefficient of variability will be the mean divided by the standard deviation. And then we also calculate the shared quantity, the percentage of the contribution on the total sales in quantity, which is the total the quantity of the item divided by the total quantity multiplied by 100. Then we push that, so we return that with the item, the total quantity, the percentage of share, which is the x-axis, the mean, the standard deviation, and the coefficient of variability. So here I have put that as optional, but you can also reorder that, but we don't need it for the ABC XYZ analysis. I put it in optional because if you want to optimize here for just the matter of teaching, I have redone basically the calculation for the contribution of the sales for both. But if you want to be more optimized, and we will see it's very important for the speed, you can sort by the descending order, so that way you can use this output to directly generate the Pareto chart. And then you return that. What else is needed is just adding the mapping. So here as you have sorted that from the descending order, you do it again in case you haven't done it the same way I did before. This is the type of, I would say, precaution that you can do, especially if you want to deploy kind of a workflow like this where data leakage or issues can happen. So here, at least you are sure that when you are going here, it's well sorted. If it's already sorted, then it's useless, but never. For optimization purpose, maybe I would remove that, but just to make sure that the job is done, I would keep it. And then what you do is you calculate the cumulative contribution that will be used for the mapping of A, B, and C classes. So the top 5% are the A class, then the remaining 50% are the B class, and then, the following 50%, so going from 5% to 20%, it's like 15%, and then the remaining are Cs. And then you return that, and you have the ABC class here, the cumulative share, which is the x-axis, but you take it in percentage, and the standard deviation here. You send that to the ABC XYZ sheet, and then it's used here to create these two visualization. So to be very frank with you, what happened is that to have this kind of column mapping, where you have in red the A, in green the B, and the rest in C, it's a bit more complicated than just having this data in this format. You need to create 3 different data sets, and for each one you take the color. For that, I have created this app script inside the Google Sheet. You just have to run it. So what will happen is when we are going to run the workflow, you will have data here. And then what you do is you run these scripts, and it will prepare this, create this sheet, prepare the data that way with A, B, and C transactions, and then generate this visual. So now, for the sake of the experiments, I will remove these 2 parts and calculate the time that is needed for the overall workflow. Let's consider that here I have pinned the data, so that way it doesn't, I would say, affect the speed. And we are going only to focus on the data processing here. So let me launch a workflow. So what we see here is that we have, for the 2 first one, the results in less than 500 milliseconds. Okay, maybe let me go on the overview here. So we have the workflow done in 13 seconds. What we can see is that this processing part are taking less than 500 milliseconds, and most of the time is on sending the data to the Google Sheet. So I don't know what to say about that. I just want to compare that with what would be done with the FastAPI backend. So now we can start to try with the n8n, the FastAPI microservice. So I have launched the Docker container, so it's ready to be called by the n8n workflow. Let's go to the n8n workflow. So it's a way simpler one. All these two nodes are now replaced with a single HTTP request node directly connected to a Google Sheet. So let's launch it. Here we have, for the first step, 134 milliseconds. The other one was quite close, in terms of processing speed. Here, the second one is 73 milliseconds. But the main difference is mainly on the time that is required to upload data to the Pareto sheet. But we have 30 seconds for the other, 10 seconds here. The difference is not that huge. The results look like to be the same. And we can try that in this Google Sheet that is directly connected to the workflow with the FastAPI. And if we look at the visualization, it's roughly the same. But here we don't have the daily stores sales because we're only focusing on the two first one. But so what we can see is that in terms of speed, you don't have huge difference. Maybe we should compare that with more advanced data processing task and also bigger data set. What I can tell you is that I'd used only 17,000 rows. It's because if I use more, then the n8n instance, or at least my UI on my browser will crash. So that's the main difference, I would say. And this is where probably you would want to not rely on the Google Sheet as input data. But for the rest, we can see that the job can be done with both approach. The main difference is that here you have a black box, and the other one, you have complete visibility of what you're doing. If you have any question, feel free to use the comment section. I will try to provide more visibility next time. If you have any question about the workflow that I shared or the connection between FastAPI microservice and these kind of solutions, feel free to use the comment section.